Alright, let's talk about doing things right the first time. When you're wiring a home, you can't just start throwing cables in the walls, you need a plan. This is your foundation, and if you mess this up, the whole job is compromised. We're in a beautiful modern house here in Kigali, and the first step is always mapping everything out. You need to walk through every single room and think about how you live in that space. Where do you need a light switch? Where will you plug in your phone, your television, or a kitchen appliance? Get a tape measure and a pencil, and mark these spots clearly on the wall. Don't rush this. A little extra thought now saves a lot of headaches later. Once you have your marks, it's time to create the pathways for your wiring. This is called chasing. In many Kigali homes, we're working with brick or block walls, so you'll need a wall chaser or a good old-fashioned hammer and chisel. The goal is to cut neat straight channels into the wall, running from the switch or socket location up towards the ceiling or down towards the floor. These channels need to be deep enough and wide enough to hold your PVC conduit pipes. This is dusty, hard work, so you absolutely must wear your safety gear. I'm talking safety glasses, a dust mask, and good gloves. Believe me, you don't want brick dust in your lungs. Make it right. Safety is not a suggestion, it's a rule. Before you even think about picking up a tool, make sure the main power to the house is completely shut off. Find the main breaker and turn it off. Then, use a voltage tester to double-check that there's no live electricity where you're working. I've seen too many people get a nasty shock because they skipped this simple step. It's not worth the risk. Your safety and the safety of your family is the most important part of any job. We're building a safe home, not a hazard. Always check, and then check again. Now think about the local rules here in Rwanda. The Rwanda Utilities Regulatory Authority, or RURA, has standards for a reason. They're there to keep you safe. For standard sockets, a good height is about 30 centimeters from the finished floor. Light switches are usually comfortable at about 1.2 meters from the floor. Use a spirit level to make sure your markings for back boxes are perfectly straight. A crooked switch or socket looks unprofessional and sloppy. Taking the time to measure twice and get everything perfectly level shows you care about the quality of your work. Do it right, because you have to live with it. With your channels cut, the next step is to install the PVC conduit. This plastic piping is like a protective tunnel for your electrical wires. It guards them against damage from moisture, pests, or a stray nail down the road. You can't just lay wires directly into the brickwork, that's dangerous and against regulations. In Kigali, you want to use high-quality, durable PVC conduit that won't crack or become brittle over time. Measure the length of each channel you cut and then cut your conduit pieces to fit. You'll also need back boxes, which are the plastic or metal boxes that your switches and sockets will screw into. Fitting the back boxes is your first task. Place a back box into each hole you made for a switch or socket. Use a bit of cement mortar to secure it firmly in the wall. You want that box to be solid as a rock, not wobbly. It should sit flush with what will be the final surface of the plastered wall. Once the back boxes are in place, you can start fitting the conduit pipes into the channels. The pipes will run from one box to another, or from a box up to the ceiling space, where they will eventually connect to the main circuit. Use saddles or clips to hold the conduit securely inside the channel. Connecting the pieces of conduit is crucial. You'll use special couplers and elbows to join straight pieces, or to go around corners. Make sure every connection is tight. Some electricians use a special PVC cement to glue the joints together, creating a completely sealed system. This is a great practice because it stops any moisture or debris from getting inside and damaging the wires later on. A continuous, sealed pathway is what you're aiming for. Every detail matters when you're talking about electrical safety. Take your time and make sure every piece is connected properly, creating a smooth path for the cables. After all your conduit and back boxes are installed and secured, it's time to cover them up. You'll plaster over the channels, embedding the entire conduit system into the wall. This is why you needed to make sure everything was flush and secure earlier. Once the plaster is applied and is dried, the only things visible will be the openings of the back boxes. The result is a clean, professional finish, with all the protective pipework hidden from view. This protects the wiring and gives you a smooth wall, ready for painting. This is how you build a system that's made to last. It's not just about looks, it's about building it safe and strong. Now that your conduit system is hidden neatly in the walls, it's time to run the electrical cables. This is like threading a needle, but on a much bigger scale. You'll use a tool called a fish tape or a draw wire. This is a long, flexible steel or nylon wire that you push through the conduit from one back box to another. It can be tricky, especially around bends, so you might need to push and pull a little to get it through. Once the end of the fish tape appears at the other box, you have your pathway ready for the actual electrical cables. The type of cable you use is incredibly important. In Rwanda, for standard lighting circuits, you'll typically use 1.5 mm squared twin and earth cable. For socket circuits which handle bigger loads like a kettle or an iron, you must use a thicker 2.5 mm squared cable. Using the wrong size cable is a serious fire hazard. A cable that's too thin for the electrical load will overheat. Strip a small amount of insulation from the ends of your electrical cables and securely attach them to the end of the fish tape. Then, go to the other end of the conduit and gently pull the fish tape, drawing the cables through the pipe until you have enough length at both ends. With the cables pulled through, you can start connecting your switches and sockets. Let's start with a socket. You'll have 3 wires, live, usually brown, neutral, usually blue, and earth, green and yellow. Carefully strip about 1 centimeter of the plastic insulation from the end of each wire. Look at the back of the socket. You'll see terminals marked L for live, N for neutral, and E or an earth symbol. Loosen the screw for the live terminal, insert the brown wire and tighten the screw firmly. Do the same for the blue wire in the N terminal and the green and yellow wire in the E terminal. Give each wire a gentle tug to make sure it's secure. Connecting a light switch is similar but simpler. A basic one-way switch just interrupts the live wire. You'll have a live wire coming from the power source and another live wire going to the light fixture. Both of these are typically brown. You connect one wire to the COM or L1 terminal and the other to the L2 terminal. This allows the switch to open or close the circuit, turning the light on or off. Always connect the earth wire to the terminal in the metal back box for safety. Once all wires are securely connected, carefully tuck them into the back box and screw the switch or socket plate onto the wall. Make it neat. The final and most critical piece of the puzzle is the consumer unit, also known as a distribution board or fuse box. This is the command center for your home's entire electrical system. It takes the main power coming into the house and distributes it safely to all the different circuits, your lights, your sockets, and your appliances. For a modern home in Kigali, you must use a consumer unit that has both miniature circuit breakers, or MCBs, and a residual current device, or RCD. The RCD is a life-saving device that cuts the power instantly if it detects a fault, like someone getting an electric shock. Installing the consumer unit is a job that requires maximum concentration. It should be mounted in a dry, accessible location. All the cables you ran from the different circuits will end here. Each circuit gets its own MCB. For example, your lighting circuit with 1.5 mm squared cables will be protected by a 6 amp or 10 amp MCB. Your socket circuit with 2.5 mm squared cables will need a 20 amp MCB. The live wire from each circuit connects to the top of its designated MCB, and all the neutral wires connect to a neutral bar inside the unit. All the earth wires connect to an earth bar. Connecting the main power supply to the consumer unit is the final step, and it is the most dangerous. This involves heavy-duty cables coming from your electricity meter. This is the point where I have to be very clear. If you are not a qualified, licensed electrician, you should not be doing this part of the job. It's one thing to run wires in a wall, but connecting the mains requires a professional. They have the training and the tools to do it safely and to make sure it complies with the standards set by the Rwanda Energy Group. They will also test the entire installation to make sure it's safe before turning the power on. Once the professional has made the final connections and tested everything, your system is complete. They will check each circuit for continuity and insulation resistance. They will test the RCD to ensure it trips correctly. This final testing is not optional, it's essential for the safety of your home and everyone in it. When you build for the long term. Taking shortcuts with electricity is a gamble you can't afford to lose. So, do the prep work right, use the right materials, and when it comes to the final hookup, call in a pro. That's how you make it right.